Okay, guys, example number 3 says graph the function h that pairs x with the expression 2x squared plus 4x minus 3. Hey guys, guess what? Okay, can't get this going. Here we go. Y equals 2x squared plus 4x minus 3. Does that make you feel better if I just get rid of that? Okay, fine. If that makes you feel better. A equals 2, B equals 4, C equals negative 3. First thing I want to do is find the vertex. You have to remember to find the x-coordinate of the vertex first, and you do that by solving or simplifying negative b over 2a. So I'm going to rewrite it with parentheses and then plug in, because that makes sure that I get the signs right. So I plug in 4 for b, and I plug in 2 for a. And when I simplify, I'm going to get negative 4 over 4 is equal to negative 1. So x is negative 1. All right. Now I'm going to erase this because you guys can pause it and go back and look at it if you want, but to give us some room. So then I'm going to plug in negative 1 for x. So in this case it was h of x, I think. Let's just see. All right, yeah. So h of negative 1 is equal to 2 times negative 1 squared plus 4 times negative 1 minus 3. H of negative 1 is equal to 2 times 1 minus 4 minus 3. I just squared the 1. Okay? All right? So h of negative 1 is 2 minus 4 minus 3. Negative 2 minus negative 5. Okay. So the vertex is negative 1, negative 5. Here and then here. Okay, now a is positive, so I know this thing is going to turn up. Okay? We'll see how wide it is in just a second. Let me get rid of this work that I did here so we'll have some room. Now, you guys can pick your own x's. I'm probably going to pick, I'm going to find x equaling 1, right? That's 2 on the right, and then x equals negative 3, 2 on the left. Okay, so let me plug those in and see what I get. I'm going to get, if y is equal to 2 times 1 squared plus 4 times 1 minus 3. Guys, you notice that I use y and h of x synonymously because they are the same thing. I just interchangeably. I just change them in and out. All right, so y is going to be 2, and then that's plus 4 minus 3, and then that's going to be 6. 3. Okay, so here's one point. If x is 1, then y is 3. Okay, I'll go ahead and plot that one. Whoa, x is 1, y is 3. This thing's going to be pretty narrow. I expect this one, if x is negative 3, I expect y to be negative 3, but let's see if that's true. We've got to plug it in and see if that's what we get. Because remember, parabolas are symmetrical, okay? So they're going to climb the same speed on both sides. So y is equal to 2 times negative 3 squared plus 4 times negative 3 minus 3. That's going to give me 2 times 9 minus 12 minus 3. That's going to give me 18 minus 12 minus 3. 18 minus 12 is 6, minus 3 is 3. Oh, look at that. So if x is negative 3, y is 3. Okay, negative 3, 3. Put my dot right there. And so my parabola looks something like this. Pretty narrow, right? Okay. It's turning up. Is it supposed to turn up? Sure, because a is positive. That's positive 2. All right? Good job, guys. Now you know how to graph parabolas or quadratic functions. And these are some interesting points right here and right here, which we'll talk about. Those are the solutions to the equation, or the roots to the equation. And when the y is 0, it actually gives us the solution to that equation. Okay, but we'll talk about that later. Good job on graphing this, and I'll see you at example 4.